Good afternoon, students. So in the last lecture, we were saying how to construct an AVL tree, and we had seen how to insert all the elements and how to perform the rotations in case the tree is unbalanced. So today we'll see how to delete an element from an AVL tree. Okay. Again, it's quite similar. If the tree becomes unbalanced after deletion, then we are going to perform a rotation. So in case you don't know the rotations, then you please have your book nearby from the last lecture and refer to those rotations. Okay. So there are just 4 rotations that you need to know. Now all these 4 rotations are very important. So before I continue with my lecture, do you all have any difficulties with the AVL tree insertion? Did you all understand the AVL tree? Aidan, Nikhil, Nirzar, Prabhakar, understood the AVL tree? Can you all hear me, students? Am I audible? Okay. Okay. So I was asking you about the AVL tree. So did you all understand that? Okay. I'll continue. I'll continue with the AVL tree, and you can let me know if you're having any doubts. Okay. So I'll continue from the last lecture from where we had stopped. We had constructed a AVL tree. Okay. Till here. So in the next slide, we'll see how to delete an element. Okay. So now if you are deleting an element, I would like you to perform this on your books. You have to apply the binary search tree rules. Okay, when you are deleting. So say we want to delete 53. I want to delete this element 53. So can you apply the binary search tree rules? There are 3 cases of deletion. Case A, case B and case C. Can you apply any one of those cases and delete this element 53? Delete that element and then check for the balance. Check for the balance factor of the remaining nodes on that same path. So once you delete this element 53, you're going to check all the nodes along this path till you reach the root. And if any of the nodes are unbalanced, then you need to apply the rotation. I'll show you how to apply the rotation, but can you delete this node? Which case will you apply to delete this node? You have to apply the rules of binary search tree. So can you all tell me, Avishka, which case of deletion will you apply in binary search tree? Case A, case B or case C? Yeah, okay, I'll keep the question open to everyone. So can you all tell me, I want to delete 53, so which case will you apply? Case A, B or C? Yes, correct. Case A. So case A, correct. Okay, so we are going to apply case A. So in case A, why you are applying case A? Because 53 is a leaf node. Okay, so can you delete that 53? Delete 53 from that tree. Okay, delete this node. Delete this node. It's a leaf node. So you will delete this. So after deleting this node, by applying case A of your binary search tree, okay, applying case A of binary search tree, so you deleted this node. Then you will check the balance factor of this node. Check balance factor of 17. Okay. Check the balance factor. What is the balance factor of 17? You can type in the chat. Balance factor of 17 is balance factor 17 is 0. Correct. Balance factor 17 is 0. Okay. So once you have deleted 53, your tree will look like this. You have removed 53. Okay. Then you are checking all the nodes that are there on the path to the roots. So checking the balance factor of 17. Checking the, like we had discussed, in a year can be +1, 0 or -1. So since this is a valid balance factor value, we go towards this root, this node, and calculate the balance factor for this node. So balance factor for this node is the nodes that were connected to 53. So all the nodes from the root node towards 53. So like you know, 53 was connected here. So once you have removed that 53, you check the balance factor of 17 first. The balance factor comes proper. By proper, I mean it should be +1, 0, or -1. So it comes 0. Okay. Since it is valid balance factor value, you go towards this other node that you need to check the balance factor and calculate the balance factor for 14. You can type the answer in the chat, whatever you get. Yes, yes. So Aniket, Reeve and Prajwal have got that +2. Okay, Prajwal, it is +2, not just 2. So it is +2. So that means the tree is unbalanced. Okay, this tree is unbalanced. So we need to balance it. We need to balance it. Okay, now pay careful attention to what I'm going to tell you. Okay, the moment you get a plus sign here, you get a plus sign. This is, you have got a plus sign here. That means your left side of this node. Okay, the unbalance is caused by the left side of the node because you are getting a plus sign. If the unbalance was coming like this, -2, okay, then because of the minus sign, you would have known that the unbalance is coming because of the right subtree. But here, since it is +2, we know that because of the plus sign, the unbalance is coming from this left subtree. This is the left subtree of 14. So I have to determine from this left subtree which rotation is to be applied in order to balance it. Okay. Please remember this. Okay, so depending on this sign that you get, plus or minus, that will tell you where to check for the unbalance. So since I've got a plus, plus will tell me that left subtree of this node is causing the unbalance. Okay, so I have to apply the rotation to this part of the tree in order to balance out this. Okay, so I'll show you how to do that. Now this is the node which is having a problem. Okay, so like always, wherever the problem, the balance is not proper, that node will be labeled as A. Okay, that node will be labeled as A. Now like I told you, because of the plus sign, the unbalance is in the left side, so I'm not going to look at this right side. Okay, this node I'm not going to look at all to balance. This is proper, so I'm not going to look there. So I have to go to the next. So my next node, according to the rotation, if you remember, always after A comes B. So I am only having one node, 11, which is the left child of 14. So this one will become B. A is always a node having a not a proper balance value, balance factor value. Next node is B. Now I can decide that 7 will be C or 12 will be C. Any one of these two nodes can be my C node. Okay. Okay. So I am talking with regards to this the rotation. Okay, like A, B, C. Okay, so this is, suppose it was LL rotation, then A, B and C would be like this. Some other rotation like we had seen last time, and A, B and C would be like this. Okay, now you know that looking at this diagram that we have drawn just now. Okay, you got here A, you got here B. B is the left child of A. Okay, so you have to find out the rotations where it is like this, where A is the root and B is the left child. So when you see like that, you will find that LL rotation is like that. A is there, root, B is the left child. Similarly, there is one more rotation. Here, okay, LR rotation, where A is there and B is the left child. Now you have to decide whether you're going to apply the LR rotation or you're going to apply the LL rotation. Why? Because these two rotations are suiting that. Okay, suiting the current problem that we have where it is unbalanced. So we have got A as the root and B as the left child. And only in these two rotations it is like that. Okay, we will check in the other rotations. B is the right child. Here you can see B is the right child. Okay, so I cannot apply this rotation at all there. So I have to only decide between LR rotation and LL rotation. Okay, I hope I made myself clear. So I have to decide between these two rotations. Okay, so depending on which rotation I'm going to apply, there I will place my C. So I am applying LL rotation, then 7 will be my C. Okay, if I am applying LR rotation, then 12 will be my C. Okay, clear? So remember when I told you in the last lecture, when I was teaching you this, I told you that LL and RR are single rotations. Okay, LL and RR are single rotations, and RL and LR are double rotations. Okay, so whenever you have a choice between applying single rotation or double rotation, we will always go for single rotations. Okay, they are less complex for the computer to apply. In this case, although I had a choice between applying, I could have applied here LL rotation, or here I could have applied LR rotation. Okay, L, left child, 11 is the left child of 14, and 12 is the right child of 11. So LR. So I could have applied any one of these two to balance. But like I told you, if we are given a choice between a single rotation and a double rotation, we always go for a single rotation. Therefore, I will go to apply LL rotation. Okay, clear? So I just again repeat this just to make it clear. The problem was here. Okay, we got +2. So this node becomes A. Okay, then because of the plus sign, we know that the problem is not in the right subtree. So I do not check here. I go below this B. So this is the left child of this. So this is L. Okay, then the C could have been here, or C could have been here. So if I would take 12 as the C, then it should have become LR rotation. Okay, but if I take 7 as the C, then it becomes LL rotation. So when we are having a choice between the single rotation and double rotation, we always go for single rotation. Therefore, I am going to apply the single rotation, which is LL rotation. So my A will be 14, B will be 11, and C will be 7. Okay, and then according to this diagram, I'll label the remaining. So 1, 2 are the left and right childs of C. So I will have here, this will be 1, this will be 2. Okay, just from here. Then the right child of B is 3. So you will call the right child of B. This is B now, 11 is B. So right child of B is 3. Okay, and right child of A is 4. This will be 4. Okay, now this node is extra, it is not there here, but whatever is connected to 12, you will keep this connection like this. So this entire thing you will think is as, you will think that this entire thing is as tree. Okay, and you will attach 13 as the right child of 12, and then you are going to apply the rotation like this. So B will become the root, C will become left child, A will become right child, 1 and 2 will be the left and right child of C, 3 and 4 will be the left and right child of A. Okay, that is the way you are going to apply the rotation. So when you rotate it by applying LL rotation, you can write here, applying LL rotation, you can write LL rotation. When you apply this LL rotation, okay, you will get like this. You will get it like this. The tree will get rotated and it will be balanced. Like I told you, this labeling, whatever I told you, will remain. Okay, you can check this from this slide, is just matching with this rotation here. Okay, so this is what was the LL rotation, 1, 2, 3, 4, and when you rotate it, it will look like this. So you have to know this rotation by heart on this slide that is there in order for you to balance this. Okay. And like I told you, this 13 is not there in that diagram, but you consider this entire thing as 3, and then you attach 13 just like that to the right of 12. Okay, now you can check the balance factor of the entire tree and it will be balanced. Okay, you can verify for yourselves. So this is how you have to do deletions in a AVL tree. After doing deletion, you need to keep checking for the balance. If it is balanced, you can go to the next step. If it is unbalanced, then you need to apply the rotation. Okay, so well understood. Any questions for me about this deletion? Any doubts? Chintan, Cheryl, Athena, Anthony, Anjali, Avishka, Dhruvi, Enid, got it? Did you all understand? Is it okay? Okay. Just for your information, I have uploaded that last previous lectures video on the YouTube, so you can check it out. Okay, in case you'll need some revision or to refresh yourselves, you can check it out. And also, I'll be uploading this video as soon as possible. So I think then, if you'll have understood, then this covers it. If you'll have any doubts, ask me right now, or I'm going over to the next topic. Okay, is it okay with everyone? Okay, then this covers AVL tree. Okay, so basically I've shown you how to construct a AVL tree and delete elements from the AVL tree. I've told you about the rotations. I've told you why we require AVL trees. Okay, so we go over to the next type of trees that we need to learn, and this is the last topic on trees in your syllabus. Okay, and this is B trees. So we'll study B trees quickly. What are B trees? And then we'll try to do the insertion and deletion in B tree. And then there's a last topic that remains in your syllabus, that is graphs. Graphs I will start most likely tomorrow's lecture, and then it will get over by the end of the your syllabus. Okay. So let's start with your B trees. So basically this is the definition of your B tree. Okay. Now remember, B tree does not stand for any short form of binary tree or anything like that. Name only is B tree. Okay. So basically you can just read this definition, and these are the properties of a B tree. So in general, for you to understand what is the B tree is just like a binary search tree. Okay, where the binary search tree, the left side is less than the root and the right subtree is greater than the parent. So in the same manner, in a B tree also follows something similar like this, except that in each node you can have more than one value. Okay, so in a binary tree or binary search tree or AVL tree that we have been studying, each node is to have only one value. So whenever you have more than one value in a tree and more than a single branch, okay, then that kind of tree will be like known as a B tree. So there will be something like known as an order that will be given to you. So suppose you say B tree of order 5. Then this order will be very important for you to decide how many values will be there in each node. Okay, it will decide maximum number of values in each node and also minimum number of values in each node. So normally those values could be also known as children or keys. Okay, so the nodes are normally known as children, and the values inside those children will be known as keys. The one important thing that you should know in a B tree is all the leaf nodes will be at the same level. It cannot be that you will have a B tree where one leaf node is at level 1, some other leaf nodes at level 5 and so on. Okay, it's not possible. If you have done something like that, then you have made a mistake in your construction of your B tree. So going over to this next slide, just note down some of these properties here, that all non-leaf nodes have at least m divided by 2 children. Okay, where m is the order. The root is either a leaf node or it has from 2 to m children, and a leaf node contains no more than m minus 1 keys. These are the main properties that you need to know. Basically, a B tree looks something like this. So suppose this is a B tree of order 5, say. So you will have a root node. Okay. Then just like your binary tree, you will have branches. So you are having a left child and a right child. Okay. The left child of this 17 is having two keys which are less than 17. So these values on this left side are less and the values on the right side are greater, just like a binary search tree. On the right side of 17 everything is greater, on the left side of 17 everything is less than 17. Okay. Again in this node there could be two or more values. Okay. So it is just based on this property. So all non-leaf nodes will have at least m by 2 children. So if the order is m is 5, 5 divided by 2 you will have 2.5, but at 2.5 can be rounded up or rounded down. Okay. So depending on that you will have that many number of keys in each node. Okay. So basically what you will see is, okay, these are the branches. So this branch here, okay, it will come before this value tree. Okay, please note. So what it means, these values here are less than this. So you can see here these values 1 and 2 are less than 3. Okay, this branch will come in between 3 and 8. Okay, it will come in between. What it means, 6 and 7 is greater than 3. 6 and 7 is greater than 3, but 6 and 7 is less than 8. Okay, and this branch will come after 8. Okay, when you're placing the branches you have to be careful. This branch will come after this 8. That means these keys here 12, 14 and 16 are greater than this value 8. Okay, so similarly here it means that 3 and 8 are less than 17. This branch will come before 17. Okay, this branch, since these are less values, 3 and 8 are less than 17. Therefore this branch will be placed after 17. You cannot put this branch here. Okay, after 17 it has to come before 17. Whenever the values are less, the branch has to be placed before. Okay, so this branch will be placed here. And these values are greater than 17, so the branch will be placed like this after 17. You can start from inside this like this. And same way, like I told you here, 25 and 26 is less than 28, so this branch will be placed here. These two values are greater than 28, less than 48. So the branch is in the middle like this. And these values are greater than 48. So this branch will be placed after 48. Okay. This branch are greater than 48. So this will be placed after 48. So we'll see how to construct this tree. It is very simple. So basically almost like going to insert in the form like how you insert values in a binary search tree. Rules are somewhat similar, only you have to make use of these additional properties that are given to you. Okay, this basically the third, fourth and the fifth property you have to keep in mind. So from the next slide onwards we'll see how to insert into a B tree. Okay, you can just note down this slide, take a screenshot or something of this. You can refer to this as we are doing the insertions. So when you're going to insert a value into a B tree, okay, the first value will obviously become the root node. Okay, so say I'm inserting like this, say 10, 20. Just take for example two values. Okay, 10 and 20. So first value 10 will become the root. Second value 20 you're going to insert. So you're basically going to follow the rules like of the binary search tree. So 20 is greater than 10. So 20 will be placed on the right of 10. Okay. So you are going to draw this like this. Clear? So basically, when we are, what do you mean by this? If leaf is not full. If leaf is not full, you are going to add a key like I added here. Okay. What you mean by that is, what you mean by that is, okay, there's a slight mistake. I just told you a mistake. Just ignore this. So when you're, I'll show you in the next slide what we are doing. Okay, just ignore this, what I just mentioned. So what I mean by this, if leaf is not full, means that a leaf node should not contain more than m minus 1 keys. So if I'm saying order 5, then the maximum number of keys that it can contain is 4. Okay, that is the meaning of that. So if it is not full, when I will say it is full, suppose it is a B tree of order 5, and if it is having 4 keys, then I will say the leaf is full. Okay, that is the meaning of leaf is full. So if leaf is not full, then I will add the key. If leaf is full, and depending on the order, if the order is odd, suppose order is given is 5, then I will apply this third A rule, where the lowest n by 2 keys are placed in the left leaf and the highest n by 2 keys are placed in the right leaf, and the middle key is placed in the father node. But if the order is even, then I will apply this rule. Question, that is rule 3b. Okay, so I will show you this in the next slides. So let's start first. Okay, let's take this example. Say we are inserting into a B tree of order 5. So you can just note down this question in your books. Insert the following keys into a B tree of order 5. Into a B tree of order 5. You can note down all these keys that are there here. All these keys. So once you have noted down and you start solving, your first step while starting is, when you start solving, you calculate the minimum number of keys, sorry, not the minimum, the maximum number of keys that a node can hold. So you can write here max keys equal to m minus 1. Okay. So you know that m is 5. M is given as 5. So you can write here m is 5. Okay. M is nothing but the order. So max keys will be 5 minus 1 equal to 4. So when you start solving, especially when you start constructing a B tree, you need to know how many maximum number of keys that node can hold, and that you determine by from the order. And this is one of the properties of a B tree. Okay, the maximum number of keys is equal to m minus 1. So you will get 5 minus 1 equal to 4. Okay, then you can write step 1, insert 1, 12, put commas, Okay, 1, 12, 8 and 2. One, 12, 8 and 2. So you can write step 1, insert 1, 12, 8 and 2. Okay, it's underlined here what we are inserting. Now, next step, you draw one. You can draw either a rectangle like this, or you could also draw oval. Okay, anything. But you can, I think it's better you follow what is there on this slide. So you can draw one rectangle like this. Okay, and once you have drawn the rectangle, now you are inserting these values. Okay, so you are inserting these 4 values. Why inserting 4 values? Because we have decided that the maximum number of keys that we can have in a node is 4. Okay, therefore we are taking 4 values. Okay, because it does not violate the condition. Once I take these 4 values, I sort them. So I write it as 1, 2, 8 and 12, and I insert it into a leaf node. Okay, so I take 4 keys at a time in this first step, because the maximum keys we can insert without violating the B-tree condition is 4. And this is the first leaf node that I create. Okay, if I would take this 5th element 25 and I would try to put it in this node, then it would violate this condition. Okay, it would violate this condition. Therefore, I do not insert 25 here as of now. So in the second step, okay, in the second step, you can write insert 25. So in the second step, you can write on your books insert 25. So now when you try to insert 25, you will insert 25 here itself. Okay, now this is your second step. So what you will do is, again you will write like this. First pay attention, okay? You will write 1, 2, 8, 12 and 25. Okay, when you write 1, 2, 8 and 12 and 25, obviously you have violated the maximum keys. Your maximum keys was 4. So whenever this happens, whenever you are inserting into a leaf that was full, then we are going to apply this rule. We are going to apply this rule. So when the leaf is full and we are still inserting, we need to apply this rule, because the order is odd. The order is odd. See, order is 5 is odd. What it says, the lowest n by 2 keys are placed in the left leaf. Okay, so you divide this, take n. N is nothing but 5, which is the order. Okay, you take 5. 5 divided by 2, you will get 2.5, but you just round it up to 2. Okay, so the lowest 2 keys are placed in the left leaf, and the highest n by 2 keys are placed in the right leaf. So again, when you divide this, you will again get 2.5. So you can just take this, you can just round it off to the nearest integer. Okay, so when you round it up, you can round it up 2.5 to 2. Okay, so you place 2 keys in the left leaf, 2 keys in the right leaf, and then the middle key will be placed in the father node. Clear? So now what we will do is, I will take 2 keys from here. So the first 2 keys I will put in the left leaf. The highest 2 keys I will put in the right leaf. Okay, so 1 and 2 I will put in the left leaf, 12 and 25 in the right leaf, and the middle key I will push up and make one more node known as the father node. So I'll put 8 there. Okay, I'll put 8 there, and this will be the left leaf, which will have 1 and 2, and 12 and 25 will be the right leaf. So when you do it like that, it will look like this. Am I clear? Please let me know if you have not understood. Did you all get this? Why we are doing it? Srishti, Siddesh, Siddhant, Steven. Did you all get it? Ruben, Roshni. Did you all understand what we did? Should we continue? Okay. So basically when 25 comes, what we do, we add it like this, but because we were violating the condition, I apply this rule. Okay, when I apply the rule, the lowest 2 keys will be put in the left one, highest 2 keys will be put in the right one, and the middle one will be taken to the parent. Okay, and when you do it, it will look like this. Okay, once you have done that, you take this value now. Next, 6. Now 6, again you have to insert it in the proper place. So when you insert 6, you see that 6 is less than 8. 6 is less than 8. So 6 should be placed on the left side of 8. Okay. Now you check here, you have to insert 6 in a leaf node. So you have to insert 6 in this leaf node. So if the leaf node is not full, you can insert 6 here directly. So is it full or not full? If it is full, the maximum number of keys in that node should be equal to 4. But here there are just 2 values. That means 6 can be safely put here without affecting the B tree condition. So we do not violate any condition. Okay? Clear? Similarly, now if you take the next one, 14. 14 is greater than 8. 14 is greater than 8. So it will be put on the right side of 8. Okay, it will be put on the right side. So when you come here, 14 will be put in this leaf node. When you are going to insert 14 here, check whether this condition is violated, max keys. Okay, here there are only 2 keys and maximum we could have had is 4. There is no violation. So 14 also can be inserted here without any problem. Clear? Similarly, 28. Okay, 28 is again greater than 8. So again 28 also will be put in this leaf node. Okay, so when you insert it, it will look like this. Okay, 6 was less than this, so it got added here. You have to put it, while inserting here, make sure that you are putting in the sorted order. The smallest one is first and the largest one is at the end. Okay, this branch will be attached before 8. Similarly, you have added 14 and 28. So 14 you will add in between these 2 values. So 14 is added here and 28 is added here. Now if one more value comes in this node, which is greater than 8, then what will happen? Again you are going to apply this rule like this, how we did the splitting. You are going to apply this 3A rule and you are going to split this. So the middle key of that will be placed in the father node here. You are not going to create one more node because each node can have maximum 4. Here there is only one value. when you split this one, left child and you will get a right child, middle one will go up to the parent. Okay, I'll show you in the next slide. So till here I hope you have understood. So 4 values we have inserted. Let's go and see the next one. So now we are trying to insert 17, 7. So first we'll see what is 17, how to do 17. Okay, so I'll show you here only on this slide. When I'm inserting 17, okay, 17 is greater than 8. 17 is greater than 8. So you're going to insert it here in this leaf. Okay, so when you try to insert 17 here, this is the place for 17. This leaf condition is violated. Maximum keys you could have had is 4. Right now you are having 5. So what you will do, you will take this 17, this is the middle value now, 17, and you will put it in this. So you will get here, you will get 8, you will get 17. Okay, you will get 8, you will get 17. This will remain as it is. So you will get here 1, 2, 6. This will remain as it is, nothing will change. Okay, but these two nodes, these two values will become the left child. So it will become 12, 14, and 25 and 28 will become the right. So you will put here 25 and 28. Okay, so that was 17. Now when you are inserting, say the next value 7. Okay, always you have to insert, like I told you, in the leaf node. So 7 is less than 8. 7 is less than 8. So you will try to insert 7 here. So since maximum keys I could have is 4, so I will have here 1, 2, 6 and 7. Next I will try to insert is 52. Now 52 is greater than 8, is greater than 17. So 52 will come here on the right side. So I will have here 25, 28 and 52. Okay, are you getting the idea? So 25, 28 and 52. Next, 16. Can you all tell me where will be 16? In which node? The which leaf node? The first one, the second one, or the third one? Which leaf node will 16 go into? Yes, correct. 16 will go to the second one, the middle one. Okay, 16 will go to the middle one. So you will have, so you have to keep inserting like that till the nodes don't become full. The moment the node becomes full, I have told you how to split it. To split it. Okay. When a node becomes full and you're splitting it, that when the node becomes full, you call it as an overflow condition, just like a stacks. Okay. When a node has an overflow, then you have to split it and take the middle key to the parent. Okay. So can you try this remaining? I have told you till 16. So can you try this remaining, and we can check then what you are getting. Try this remaining: 48, 68, 3, 26, 29, 53, 55, 45. So after entering these 5 values, it would have looked something like this. Okay. So once you enter add 7, 52, 16 and 48, it will look like this. When you're drawing the branches, just be a little careful here. In the slides is not proper. This branch should come here before 8. Okay. This branch should be in the middle and this should come after 17. Same here. This is before 8 and this is after 17. Just be careful. So 68. What will happen to 68? Let me ask someone. 68. Sunresh, can you tell me what will happen to 68 when you're inserting 68? What will happen to this here? 68. Will 68 will be put in which leaf node? First of all, you tell me that. The first one, second one, or the third one? Sunresh, where will 68 be put? Which leaf node? First, second, or third? Yeah, I'll open the question to everyone. Where will 68 be inserted? Which leaf node? First, second, or third? Correct. It will be inserted in the third one. So when you insert 68 in the third one, what will happen? Will any rule get violated? If a rule will get violated, then what will you do? When you insert 68 here, okay, 68 you will insert here in the third one. Maximum number of keys that you would have is 4, but you are having here 5. What you will do? You will split this. So you will split this, so you will have the leftmost 2 as the left child, this 2 as the right child. And this middle value will be taken on top. Okay. Applying this rule that we have studied, the lowest n by 2 keys are placed in the left leaf, highest n by 2 keys are placed in the right leaf, and the middle key is placed in the parent node or the father node. So this is what it will look like. Okay, when you insert 68 and also the other values. So if I would insert 3 here, the next value is 3. Then again, this thing would have got split. 3 would have gone on top. 1 and 2 is the left leaf. 6 and 7 is the right leaf. You have to split the parent, Siddesh. In case the parent also becomes full, then you have to split the parent also, applying the same rule. You will get again left leaf and right leaf. If you're doing it step by step, you will get this. Not shown the middle steps here. Do you all want me to show it, students? Yeah, Siddesh. New root will be single value. Malikesh, do you want me to show the steps? Okay, okay. Okay, I'll do everything on this one slide here, okay, so that you all can understand, okay. Let's do it here. So you start with this first four values, okay. I'm starting with four values because we had started with this maximum number of keys is given as m minus 1. So order was 5 minus 1, 5 minus 1, okay. So maximum number of keys I could have inserted without violating any condition is 4, okay. So I start from there, okay. So I take this first four values, I sort them out, okay, and I insert them into a leaf node. I'll make one new slide so that I can explain everything to you all. Okay, just 1 second. Okay, so maximum number of keys we can have is 4. So I take these first four values and I insert them into a leaf node. So I will have 1, 2, 8, 12. Okay, then I take this next value 25. Okay, and I want to insert it. So what I do first, I check here whether my leaf node is full or not full. If it is not full, I can add it here directly and continue. Okay, but when I check here, I see that the number of keys here is 4 and my maximum also allowed is 4. So it violates the condition. Whenever the condition is violated, I have to apply this rule. Okay? I have to apply this rule where lowest n by 2 keys are placed in the left leaf and highest n by 2 keys are placed in the right leaf and the middle key is placed in the parent node. So remember that rule, okay? So what I do is I add that 25 here, okay? Then I find out what is n by 2. So n by 2 is equal to 5 by 2 equal to 2.5. So I round it up to 2. Okay. So here it was told to me lowest n by 2 keys will be placed in the left leaf, highest will be placed in the right leaf. So I found out what is that n by 2. So n by 2 is 2. So I decide which are my lowest keys. These are my lowest keys 1 and 2. So this will be put in the left one and the highest ones are 12 and 25. So these will be put in the right and the middle one is 8. So this 8 will be put in the parent. Okay. So based on this, I make 1 and 2 in the left leaf, 1 and 2, 12 and 25 on the right, and 8 will go to the parent. Okay, and then you draw these arrows like this. Okay, so since that is done, let me just drop this. Okay, then I take the next value 6. 6 is less than 8, so I insert 6 here. Why insert 6 directly here? Because I had only 2 keys here and 2 was less than 4. So I have placed 4 more 2 values here. Okay, maximum number of keys I can put is 4. So I can add more values here till I reach this total, the threshold. Okay, so I put 6 there directly. Next I have to insert is 14. So 14 is greater than 8. So 14 has to be put on the right hand side of 8 here in this leaf node. So I check number of keys here is 2 and maximum I can have is 4. That means I can put 14 here directly. So I sort it out and put directly. So I will get here 12, 14, 25. Next value that I have to insert is 28. Okay, 28 is greater than 8. So again I can insert 28 here in this node because there are only 3 values. Maximum I could have had is 4. So I put 28 here. Okay. Next value that I want is to insert is 17. So again 17 is greater than 8. But here now I have 4 values. Okay. So if I put 17 here, it will become invalid. So what I do now? Again I have to do a split. So I take these values 12, 14. I put 17 there. $25 and 28, and I apply this rule where we have decided that if the leaf when the leaf is full, then I'm going to apply this rule. Okay, I'm applying this rule again because the leaf is full. So again I am making left leaf. So 12 and 14 will be the left leaf. 25 and 28 is the right leaf, and 17 will be the middle. Okay, so just to show you what will happen, let me rub this. So 17 will come here, 17 will come here. Okay, 17 will come here, and 12 and 14 is the left leaf. So 12 and 14 is greater than 8, and less than 17. So 12 and 14 you will put here. Okay, this will be 12 and 14. Clear? Left leaf. The right leaf is 25 and 28. 25 and 28 is greater than 17. So 25 and 28 will come here. I hope you all are getting it. Okay. So as long as the leaves are not full, you can keep adding them. So when we call it as full, when they reach 4, when they reach the capacity 4. When you are adding the 5th one, then you have to do the split. When you add the 5th key, you have to do the split. Why you are doing the split with the 5th key? Because the order is 5. Order is 5 and maximum number of keys you can have is 4. Okay. So now once you have added that 7, can you add 7? Yes. Where you will add 7? Less than 8. So you will add 7 here. Can you add 7 here without splitting? Yes. Why? The number of keys here is 3. Maximum we could add is 4. So I can add 7 here. Okay. So I will have 1, 2, 6, 7. Similarly, 52. Okay. Where will you add 52? 52 is greater than 17. So you will add 52 here. Okay, 16. Where will you add 16? 16 is greater than 8, less than 17. So 16 will be added here. So like this you have to keep on adding. Are you getting the idea? Getting the idea? Are you understanding? Yeah, students, did you all get it? What I'm trying to tell you? Nikhil, Mohandas, Macwell, Malikesh, Athena, Reeve, Savi, Siddhant, Siddesh, Srishti, Steven, Suraya, Vibhuti, Yash. Are you getting it? What I'm trying to tell you till here, till 52, 16. Okay. So like this, you have to continue. You have to continue. Okay. So when you continue, next will be 48. Next you will take is 48. So 48 you will insert here. Why you will insert here? Because this leaf is not full. So you will insert 48 here. Okay. Next value you will take is 68. So when you try to insert 68, this will get split. This one. Okay. So it will get split. And like that you have to continue. Okay, so you can see here, this is the way it will finally look when you continue. You can continue and try this. This is the final answer that you will be getting. Okay, you can try the remaining values. And you can let me know tomorrow if you are having any difficulty. Okay, there are hardly 6 or 7 values that you have to do. So when you are doing that, okay, when you are doing this insertion, when you are doing these insertions, and suppose this parent node also gets full. Say you get 4 values here. Just for example, I will add 4 values here. Okay. So you get 4 values here. And then again another 5th value comes. Then you are going to apply the same rule. You make 2 nodes. Left node, right node. And this middle value will go on top further. So you will get here 1 more node. And then you reattach. So this leaf node is less than this, and this leaf node is greater than that. Okay, just to explain how it works. So when you do that here, okay, this will get split in future. So this gets split in future. That's how 17 goes on top. Okay, you can see here 17 goes further on top. So you get 3, 8, 17, 28, 48. So when you get 5 values in this step, when you get 5 values in this step, 28, 17 will go on top. Sometimes what happens is, okay, here what will happen is, in this case here, okay, in this case here, when you add 45, okay, this 28 goes on top. 28 goes on top. Okay, so you get 25 and 26 as the left leaf, and 29 and 45 as the right leaf. Like you can see here, 25, 26, 29, 45. Then what happens? 28 had gone on top. 28 had gone on top here. Okay, so this had become invalid. So therefore, 3 and 8 will become left leaf, 28 and 48 will become right leaf, and 17 goes on top. That is how it looks here. Okay. Then when you get that, I told you how to attach the branches. That is one question that you will have. Okay. So when you are attaching these branches, suppose this you are just having this leaf node. Okay, and you don't know where to attach this branch. Say you don't know to attach this branch, you don't know where it is to be attached. Okay, you know that 17 is the root. These two values are greater than 17. So it will come on the right of 17. Okay, then you know that these two values are 28 and 48. And this 25, 26 is less than 28. 25, 26 less than 28. So that means 25 and 26 should be attached before 28. Similarly, if you get these two values, 29 and 45, you don't know where it is to be put in the B tree. So how you will know? check with the root. 2945 greater than 17, so it should come on the right side. Then you compare with this level. 2945 greater than 28, less than 48, so this should come in the middle. This should come in the middle. Similarly, if you don't know where to attach this, same way you have to do. Okay, so just common sense while attaching these branches. There is no rule for attaching these branches. Just common sense. This is greater than 17, and these all values are greater than 48. Therefore, this will be attached here. Okay. I hope I've made myself clear on how to attach those branches. Okay, but that is one difficulty many students have. They know how to insert, they know how to split, but they don't know where to attach the branches. So please note that just common sense you have to use and attach those branches. So removal from a B tree we will see tomorrow. Okay, and we'll continue tomorrow. It's already a bit late now. Okay. So if you are having any doubts, we can still solve about these things tomorrow. Okay. And a reminder for the diploma students that you are having your IT tomorrow.